Hi guys, I'm Sharvin here.
I'm Ewan.
I'm Alan.
I'm Sean.
We are from group
Royal Derivative.
First thing first, I'm gonna hand over to Sean to explain more about derivative. Let's get into it.
Okay, hi guys. I'm going to explain to you on what is derivative and how do we use derivative in our daily lives and why is it important. So derivative, okay, is a function is changing at any given point, and also most commonly known as fx respect to x in a calculus equation or a problem. Okay, so normally function is always representing some quantity. Fx always representing some quantity like distance, speed, and temperature, and x would be the changing with respect to another quantity such as distance or time. So, okay, so that is derivative. Okay, why do we use derivative? That's a very good question, right? So most engineers and a lot of difficult work requires a lot of understanding in the rates of change, especially those really small amounts. So derivative has a very accurate calculation and it's really precise. So in example, when you're driving, you can find the speedometer shows your speed at any given moment. So that's essentially derivative on the tachometer, the speedometer. Okay, other than that, you've got optimizing decisions. Okay, design engineering, predicting behavior in market trends. You got technology, smartphones. All of your phones also uses this precise derivative in your daily basis. So essentially, derivatives are crucial for making informed decisions, optimizing processes, predicting outcomes, and understanding the world around us. They provide a mathematical framework for quantifying and analyzing change, which is fundamental to countless aspects in our daily lives. I'm going to hand over to my colleague next, so they can give you a sample problem about derivative. Thank you.
So let's start with sample problem 1. Here's the question. The volume of a sphere increases at a rate of 25 cm3 per second. Find the radius of a sphere when the rate of change of the radius is 0.2 cm per second. So let's write the information first. Volume increases at a rate. So means dV over dt is given by 25 cm3 per second. The next information, radius increases at a rate, means dr over dt, the value they given is 0.2 cm per second. And what we need to answer is, we need to find the radius of a sphere. As we all know, V is equals to 4 over 3 pi r cube. Here is the point we need to apply the derivative. V is respect to r. So we need to write dV over dr, and here's how I want to teach you how to differentiate. So first, there is the power of 3 here. So you bring it in front and times with 4 over 3. So 4 over 3 you times by 3, you get 4. And pi, and the r, the square itself is minus 1. So 3 minus 1 is 2. So r square. So v is respect to r means dv dr is equals to 4 pi r square. Next step is we need to apply the chain rule. So the chain rule goes like this. Since we need to find the radius, so the chain rule is dv dr is equals to dv over dt times dt over dr. We have to eliminate dt in order to get this derivative. So, as you all know, dv dt, the value of dv dt is 20 pi, and dt dr, as they given the value of dr dt is 0.2, when we write dt dr, we need to invert the value. So we will get 1 over 0.2. So the answer should be 100 pi. Okay. So dv over dr is 100 pi. So since this dv dr and this dv dr is same, so we need to compare the answer in order to get the radius. So 100 pi is equal to 4 pi r square. So from this we can eliminate the pi. So we cancel out the pi and we get 100 is equals to 4 r square. So we bring the 4 here, it's normal mathematics, equals to r square, we get 25 equals to r square. So just twist it, r square is equals to 25, and I bring the power of 2 together, becomes square root of 25, and then it goes down. So r is equals to 5 cm. Thank you.
Alright, so now we have sample problem 2. So sample problem 2, we have the question is about a factory produce a cylindrical cluster container for drinks. So it should be look like this. And each container has a volume of 32 pi cm cube. And so with the information volume equal 32 pi cm cube. And the cost of the material used to make the top and the bottom, so means top and the bottom of the container is 2 cent per cm square. And the cost of the material to make the curved surface is 1 cent per cm cube. This is 1 cent per cm square. And the question is asking, show the cost to make the container equal to, so cost equal to 4 pi r square plus 64 pi over r, where the r is the radius of base of the cylinder. So first we have the information V equal 32 pi, and we know that for cylinder, the formula for cylinder V equal to pi r square. So we have both V and V here, so we can do 32 pi equal pi r square hash. So the pi we can cancel out, so we get 32 equal r square times hash. So after that we can move the r square to here, so hash equal to 32 over r square. And next, we want to find the surface area of the cylindrical container. So the surface area of the container is equal to 2 pi r square, because the area for one of this circle is pi r square. So we have 2, so 2 pi r square plus, so for this one, the area is 2 pi r h. This one is the circumference of the cylindrical, so this one is 2 pi r, and this one is the height, and plus 2 pi r h. Next, we can find the cost equal to, so since for the top and bottom is 2 cents per cm square, so we can times 2 pi r square times 2 plus, and the curved surface is 2 pi r hash equal 1 cent per cm square. So 2 pi r hash times 1 times 1. And next, After we times 2 times 2 is 4. 4 pi r squared plus this one is 2 pi r. And next we substitute the hash from here into this hash. So we can get 4 pi r squared plus 2 pi r hash is 32 over r squared. And we can get 4 pi r squared plus this one is 2. So 2 times we can do it like this, 2 pi r times 32 over r squared equal to 4 pi r squared plus 32 times 2 is 64 pi r over r squared. So we can cancel out this r and r. So we have the final answer 4 pi r squared plus 64 pi equal r. So this is same as this one. Same as this one. So our answer is this. So next for B question, I'm going to hand over to my group mate to discuss about it. So thank you.
So in order to get the possible value for r, we need to derive this equation. Okay, so I start to derive. Okay, so C equals 4 pi r squared. Need to make it into one line. Okay, and then alright, so this after we derive, and then we have to make the dc dr equal to 0. And then do normal math to find r. So we get radius equal to 2. And then how do we find the height? We just sub in the height we used just now, which is 32 r squared equal h. Sub the r inside, so we get the height. So the dimension of the cylindrical closed container is radius 2 and height 8 cm.
So guys, this is our end of the session. I hope you all enjoyed our explanation and understand well what is derivative. So that's all from us. Thank you. Bye bye.
Thank you.